right. Hello and welcome to United Astronomy Clubs of New Jersey. We are back here online on both Twitch and YouTube with our presentation. Big welcome to everyone joining us tonight. Hope everyone's staying warm. We've been having quite a bit of a cold snap these past few weeks. So hopefully everyone's good and not freezing over. Uh, with that, I do want to encourage everyone to check us out on uacnj.org. It's where you're going to find information about our organization. Uh, we are a 501c3, and our biggest goal is to try and share our love of space science and astronomy with as many people as we can. And how we do that is we're actually club of member clubs made up of other clubs. So uh, one of the best and easiest ways to get into astronomy is to find your local club and join them, not only for access to various things like telescopes and the wealth of information that the members may hold. For example, out in Warren County, where we are at UACNJ, the tips and tricks I know might not be as relevant to someone living in New York City, where the light pollution is that much greater. So, like I said, do check out our website. You're also going to find a list of all our upcoming talks. We're working on filling our in person schedule when we are back on site in a mere 7 weeks' time. Someone's making fun of the fact that I can't actually talk. Yes, occasionally I can't see where I'm talking, chat. That being said, you can also check us out on our social media, our Facebook, Instagram. We have a Discord server. All of those are great places to find out what we're up to, as well as find out when we're going live or what programs we have and any special events that might be happening. With that, you're not here to listen to me ramble on. You're here to learn about what's up in the February sky. And our presenter, Lonny Buinis, is giving this talk. He's been giving the What's Up series since about the Cretaceous period when the United Astronomy Clubs of New Jersey began. He holds degrees in Stevens Institute of Technology in physics and computer science, but his arms got tired, so he has since hung them on his wall. He learned how to make space art, 3D animation, and videos, and Lonny is the only member of the International Association of Astronomical Artists to specialize in virtual reality worlds. His current projects include expanding his space history ebook and putting his pants on 2 legs at a time. And with that, here's Lonny.
Thanks. Thanks very much, Kim. This program wouldn't be possible and the whole series without Kim and other volunteers from UACNJ. So if you do visit the observatories plural at UACNJ, there are several when we're open April through October, but we're doing things virtually now. So I'm going to switch over to my computer and we're going to take a look at and see what's up in the sky for this month. I have to warn you, this month is a little sparse for activities and events, but we'll make up for that next month when there is an unexpected comet. We're looking at the sky from January 30th because I like to start with the moon first. Why don't we begin with what's up? And so on my very first image, I've got a kind of a summary of the winter sky. Looking at the sky at 20 hours, minus 12. Arithmeticians in the audience, 20 minus 12 is. You got it? That's a time when we're all still awake and looking at the sky at night, as opposed to early in the morning. Towards the south, you'll be seeing Orion the Hunter with the bright stars Betelgeuse and Rigel. Different colors visible to the eye, bluish Rigel and reddish or orange-ish Betelgeuse. Is that a word, orange-ish? Orange-like, orange-esque? There's also a constellation above the Hunter that are two bright stars in long strings for Gemini, the twins. the sign of the zodiac. But this month, there's a very bright planet Jupiter disfiguring the usual appearance of the twins. And I'm going to talk about the winter triangle of three bright stars, Betelgeuse, Procyon, and the Dog Star, when we simulate the sky, which we're going to do with some free software. But first, the moon. I like to begin with the moon. The current phase of the moon you'll find at moongiant.com. You can go forward and backwards in time to watch how the phases will change. We're heading towards last quarter moon in 2 days when the moon is in the south. I'm sorry. Yes, it's in the south, but that's going to be what you'll see if you get up at 5 in the morning and look south. That's the waning first quarter moon getting smaller. The site moongiant.com, which I don't work for, has some beautiful other features like a calendar that you can look at, you can print, you can display, with various ways of controlling the calendar, so you can get the names of the phases, the illumination, the major phases. You can make it look as confusing as you like, or take all of it off and make it look pretty. But if we're looking at the major phases of the moon, let's zoom in a little bit. Then this month, we've got them on a Sunday, a Monday, and a couple of Tuesdays. Got the full moon, which is absolutely worst or best time to look at the sky. Worst or best, what do you think? It's, as we say in astronomy, using the scientific terminology, it's horrible. Horrible time to see anything. You can't see any shadows on the moon, so there's no features visible except bright and dark areas, and also a very bright crater Tycho, which you can see with rays spraying out from the crater. It's a good time to see the rays in Tycho. Anything else, forget it. Faint stars, nope. Nebulae, gas clouds where stars are forming, and solar systems, very exciting, nope. Globular clusters, nope. You'd want to do that when the moon is new. You get a nice dark sky because the moon is not in the night sky. It's in the daytime sky near the sun. We just can't see it. Sun's light blots everything out. Last quarter moon, the moon is on the wane. It's going smaller and smaller, becoming a crescent before new. The last quarter moon early in the morning. But if you'd like to see a nice division between light and dark on the terminator, you'll see good shadow detail during the first quarter moon, which is the moon in the south as the sun is setting at night. So when the sky finally is dark, 8 or 9 o'clock, right, you go outside, take a look at the moon in binoculars or a telescope. Even a small one will show you tremendous detail with all that shadow detail. And you'll also see artificial city lights right near right near the terminator. You won't see city lights. You'll see things that look like city lights. I was wondering what that was when I looked at the moon in my first telescope when I was 10 years old, and I discovered the mountain peaks of the rising sun, mountain peaks. The sun is rising slowly on the moon. The moon goes around on its axis, not once a day, but once every 27.3 days. So the sunrise on the moon is very slow, but you'll see details there. So those are all good times to look at the moon. Now you know the worst times and the best times. Why don't we take a look at what the moon has been doing? Over the last few days, the moon's been moving out of Gemini, the twins. Let's zoom out so we can no longer see the disk of the moon, and go forwards in time from January 30th, 31st, February 1st, looking towards the eastern sky. So to get your bearings in the real sky, what are you going to do? You're going to go outside. You're going to run out there. You're going to look for that red letter E. No? Right? You're going to look for a backwards question mark coming up in the east. And a triangle in the trees for the back of a famous sign of the zodiac. Very powerful. This is the Regulus, the lawgiver, the star Alpha Leonis. Alpha, Leo. Astronomers, being peculiar people, like to abbreviate constellations with 3 letters. So each constellation has a standard abbreviation, LEO, for the constellation that happens to have its full name in its abbreviation. What is this? We can cheat a little bit. We can turn up star diagrams and pictures. You got it, Leo the Lion. The moon moved through Leo the Lion the past few days. And if you looked at the sky at 20 hours and 10 minutes, which is the current time for today, the 7th, you'll see that the moon is not there. So here's the sky in real time for tonight. Let's zoom out a bit. How do we know where the moon's going to show up later on this month? If I'm facing south, can I tell? If you know the signs of the zodiac, there are actually 13 of them. I can mark the path that the planets and the moon and the sun all take through those constellations. It's called the ecliptic, and it would be the orbit of the Earth drawn out into space if we could see it. So what do we find along this orbit of the Earth? With the solar system being so flat, we would find the sun travels along this path, the moon above and below a tiny bit, the planets Venus, Mars, Jupiter, Saturn, Uranus. There's Uranus, Neptune, planet Uranus. Can we zoom in and find it? Well, if you wanted to find Uranus, yeah, we could do that. But I'm waiting for the moon to come back. We can travel through time in Stellarium, the free software that I'm using to simulate the sky like a planetarium does. Also like a star map. On a star map, everything's very small. Orion looks like this. Do you see the hunter? How about now? How about now? In the actual sky, the angles between stars are great. So Orion's a pretty big constellation, kind of easy to find. It's got a lot of bright stars in it, including the orangey, orangish, orangesque, Betelgeuse, Alpha Orionis, Beta Orionis is Rigel. We can look along the belt of Orion and do something we amateur astronomers, yes, that's what I am. I don't get paid to do this. I'm not a professional astronomer. I've been an amateur astronomer for a long time. Started when I was about eight years old. That was about 2 years ago. The belt of Orion points past the face of Taurus, the bull. Taurus, the bull. A little bit easier if we leave the lines up that you'll see on star charts, like the kind that we sell at UACNJ. Shameless advertisement, that'll be the only one. And if we keep going, if we star hop past the bull, we'll come to something that looks like a little dipper in the sky. This is not the little dipper that we find in the north. Here we're looking south. This is a star cluster, an open star cluster, a fairly young one called the Seven Sisters or Pleiades. Every once in a while, you'll see a satellite zoom by. We have many more of these now that we're sending up a lot into low Earth orbit. This is an older star cluster that makes the face of the bull. So if we're going to look for the moon when it comes back later on in the month, can we do that? Let's see. Today is the 7th. Go to the 13, 14, 15, 16. Look at that. The moon comes back by the end of the month. On the 21st, we look in the west when after the sun sets to see a crescent moon. Sometimes you can see the dark side of the moon within the crescent, especially when the moon is a thinner crescent. Let's go back a day. Can I find the moon? There's a satellite. There it is in the trees. Let's go a little bit later. See what I did there? I jumped forward an hour. Where's the moon? Oh no. Wow, what happened? Oh, going forward means the sky sets, goes from east to west, right? If you ever look at the sky for a long time, the sun goes from east to west, the moon, the planets, the stars, everything is moving east to west once a day. That's because the sky is spinning around the Earth, correct? Nope. Right, so we're spinning on our axis, creates the day. And there's a nice thin crescent moon. And we can see the dark side right there, Earthshine. The light of Earth reflecting off of the moon makes the dark side visible. How about the other side, the side we don't see? That's lit up. If we could turn around and look at the other side, most of it would be lit up. The moon is a sphere, so it's always half lit, always half lit, but we don't always see it half lit because it's moving around the Earth. It changes our perspective. So if you want to watch the moon do some very pretty things, February 20th, 21st, 22nd, the moon is moving along the ecliptic, but a little bit higher. There's an old saying, the moon rides high in winter and low in summer. Why is that? Because the moon's orbit is not lined up with the Earth's orbit around the sun. It's not even lined up with the Earth's equator, which we could show like this. The blue line's the equator. Now the moon's way up there. The moon's orbit is tipped to the Earth a little bit, about 5 degrees. It's enough to put it high like this. So moon is riding high in winter. It'll be low down here in summer. But in summer, we won't see Orion. That's a winter constellation. And so is the bull. And so are the seven sisters. So watch for the moon to do some very pretty things through the skies. It moves back into Gemini toward the end of the month, the 26th and the 27th. It's near the planet Jupiter. Now, I've gotten ahead of myself a little bit. I'm going to come back to look at the sky, but I still want to talk about the moon a little bit. The moon's got some very poetic names when it turns full. Each month we have a different name for it. And in February, it's the snow moon. I wonder why. Today, my wife and I went out to the backyard to feed a wild rabbit that was huddling against the fence for warmth. It was huddling against the fence in 11-degree weather. I don't know what it was doing out there, but it seemed to have found a spot that was away from the wind. So we tried to throw some carrots at it, and we had to end up throwing the carrots over the fence, a couple of fences between us and the neighbors. So I finally got some carrots between the two fences where the rabbit was safely huddled, and it didn't run away. Rabbit was taking part of February's snow moon because it's cold in February. We have snow. It's not unusual. This is one of a bunch of infographics and other information at starwalk.space. Again, I don't work for them, just another reference that I use. So they have a nice calendar, and they go through each month in detail about what's happening. And I'll remind you of that when we're done with the presentation tonight. Lots of cool stuff in here, something for every month. There's a pink moon, strawberry micro moon. There are micro moons and micro and macro moons or super moons. And we talked about that before. This year, there are 3 super moons and 3 micro moons. And the next time we have one, I'll tell you what that means. But for now, whoops. There's some other events happening, not too many in February. It's a short month. It's also kind of short on events in the sky. But we have something called an elongation of a planet away from the sun. Mercury is the innermost planet from the sun. There may be some small asteroids that orbit closer, but they'd have to be very tiny or we'd have found them already. So that inner planet Mercury will look like it's on either side of the sun in the evening sky or morning sky, moving very quickly around the sun in 88 days, not 365 like the Earth. Its greatest distance away to the east happens on February 19th. So what does that mean? Which way is east? If I'm facing south, you have to look to the right for the setting sun. So what direction is that? Right, facing south to the right. The sun sets in the west. So if I'm elongated away from the sun to the east, I'm going left. That means it's a good time to find Mercury. It's going to look like this at 18 hours minus 12 is anyone? You don't have to shout it out. It's 6 p.m., where the sky is still pretty much very bright. But in stellarium, we can look at objects and see them even if there's bright light. We can see that there are several planets up at 6 p.m. Venus, Mercury, part of the Fishes, Pisces, the crescent moon, and the planet Saturn. Nice grouping, if only we could see it. It's probably too bright. But you might be able to find Mercury in binoculars. You might find Venus. This is a very low horizon, unrealistically so. I have buildings and trees up to about here where I live. I don't know about you. And every time they replace a small house here, they replace it with a house twice as tall. So it's getting very hard to see things low to the horizon. Those of you who are lucky enough to live where you can see the ocean, you might have a nice clear view down to the horizon between the sky and the ground. So Mercury is far, at its farthest distance from the sun, as seen from Earth. It's always about the same distance in its orbit, but we see it going up and down towards the sun, disappearing at times into the morning sky. Planets, both Uranus and Jupiter are out, and Neptune, Uranus low in the sky. Jupiter, if you look at Jupiter on the 19th, the same night that you can find Mercury, at 21 hours now, all right, now, come on, you're all getting good at this, right? 21 minus 12. They don't do AM, PM in stellarium. 21 minus 12 is, 11 minus 2 is 9 p.m. Jupiter it'll show off all four of its giant Galilean moons, discovered by Galileo in 1610. Wow. More than 400, more than 400 years ago. 1610. He saw all four planets, and night after night he watched them going across Jupiter and behind Jupiter like beads on a wire, back and forth. Their orbits are not tipped toward us, toward the Earth. They're pretty much on a straight line, so we can watch them going round and round. One of them has a yellowish color because of the sulfur on its volcanic surface. That's Io. Europa may be an abode of advanced life or not. We're just not sure until we go there later on this decade. Callisto and Ganymede, wonderful names from mythology. You can see Jupiter like this, even in a small telescope. You can see the moons of Jupiter in binoculars. Don't need a telescope. In binoculars or a small telescope, you won't see the goat who nourished Jupiter when he was young, Amalthea, small moon. Uranus, you might see a couple of the outer moons, Titania and Oberon, named after characters from Shakespearean plays. Planet Uranus looks like a dull, featureless disk. And again, this time I've chosen the 12th of February when all four of the major moons are easily visible at midnight. Here's a close-up. In bigger telescopes, Jupiter shows, to use a hackneyed phrase, a stereotypical phrase, a wealth of detail. I once counted about 4 or 5 of those mentioned in Sky and Telescope magazine. A wealth of detail. Yeah, because there's a lot of stuff going on in the clouds of Jupiter. See these little white spots? They're storms. They're about the size of planet Earth, 8,000 miles across. That's a small storm on Jupiter. Here's a big one. Biggest in the solar system, the Great Red Spot. Brilliant name. It's big, it's red, it's a spot. The Great Red Spot. Maybe we should call this one the Big Flattened Planet. We used to call these gas giants. We now know that they're not made of gas. They have a gaseous atmosphere, a thick one, but inside they have a very bizarre substance that behaves like a metal made from hydrogen and helium in a metallic phase. On the night of the 19th, when Mercury is far from the sun and visible in binoculars, go out on the 19th and look at 20 hours minus 12 equals. I'm not going to tell you. You'll see Io and Europa very close to one another, super close. In binoculars, it might look like one bright star. Check it out. This is what Jupiter looks like on the 19th at 8 p.m. Yes, you guessed it correctly. Kim, give that audience member a gift. No, we don't do that online, but we might give away rewards for people who answer correctly when you visit us live April through October. Or maybe not, depends on how generous we're feeling. This moon, Europa, brightest of the four and smallest, was featured and mentioned in Arthur C. Clarke's books, 2001, A Space Odyssey, 2010, Odyssey 2. Check it out, interesting fiction. Why is it the brightest if it's the smallest? It must be covered with something bright, right? Ice. There is a minor planet, the first discovered minor planet. That's why it has a number 1 in front of its name, Ceres. Ceres, the first of the asteroids or planetoids to be discovered on New Year's Day at the turn of the 20th century, 1901. Ceres, visible on the 15th at 8 o'clock. I chose the middle of the month, but you'll find it approximately there the whole month, near Pisces, the fishes, which we can take a look at in a little bit. And I keep promising you, I know, I'm not a liar. I just, these predictions were made by someone else for an explosion to happen on an accretion disk, a disk that accretes or collects around a tiny white dwarf star the size of Earth, a star the size of Earth, but a single cubic centimeter or thimbleful of that material would weigh as much as an SUV. White dwarf. That is the fate of our sun. One day the sun will run out of energy. Well, it will burn up its hydrogen. It will collapse to form a white dwarf. In this system, there's another star that this goes around. It's a red giant star because it's big and it's red. So what do we call it? Brilliant red giant. Wow. Those astronomers, man, they come up with some really original names. This is T Corona Borealis in the constellation Corona Borealis, letter T. The blaze star is another name for it. And once in a while, the material that builds up around this disk, it's falling from the red giant, but sometimes there's a surplus and an explosion happens, a nuclear explosion that makes this thing 1,600 times brighter. This brightens from magnitude 10, which would be difficult to see in my small 3.5-inch telescope, to magnitude 2, 8 magnitudes. Now, 5 magnitudes in astronomy, that's a logarithmic scale. 5 magnitudes is 100 times brighter. So for comparison, 0 for the planet Saturn, faintest star you could see with your eye in light polluted skies, magnitude 5. The numbers get higher as the things get fainter. So that's astronomers for you, doing things backwards and by multiplying instead of linear. So magnitude +2 will look like the stars that this faint star are near, the brighter ones in Corona, the crown, the northern crown, Borealis. What's Corona Australis? If any of you have ever visited the southern hemisphere, Corona Australis is what? Southern crown. Yeah, there's another one. But we have the northern crown in New Jersey. Now, Gene Schneider made some predictions that turned out in the research notes of the American Astronomical Society. She did that in 2025 or 2024, sorry. And these predictions turned out to be wrong. So we have to wait till June 25th because this thing, this dwarf star, orbits around the giant star every 228 days. So maybe they can predict eruptions, maybe. If it's not this year, it'll be next in February. 2027. So I'm not a liar. It's just that we're not sure. We do know that the thing explodes every 80 years. It did in 1946. It's overdue because I've been telling you about this since last year. It's not my fault. Ooh, I sound like a politician. Before we conclude with some reading, reading material, oh dear. Why don't we take a look at the simulated sky once again? And this time, let's get our bearings by starting in the north. And I'm going to go to my markings and turn off things that we wouldn't see in the sky. I'm going to leave one thing that we wouldn't see are lines, because you'll find these on most star charts, star maps, to make it a little easier. Star maps like the kind we sell. Oh no, I thought I was done with advertisements. The kind we sell at UICNJ or in science museums or planetaria or planetariums. Take your pick. Plural. Look it up. Anyway, if you go to a science museum or if you go to UICNJ, we sell these cheap. They look like round circles with a rivet by the North Pole so that they spin round and round. You can set it for any time of the day or night, any time of the year. Luckily, on computer programs, we can zoom in and see that this time of year at, let's go to today, shall we? On the 7th of February at 20 hours, 8:31 and 40 seconds, the Big Dipper will be here in the north. So what do? To find north, you run outside and look for the red letters? No, you won't see those. You look for the Big Dipper, which is low in the trees, so you might not find it at all. But if you can find the two bright pointer stars, Merak and Dubhe, Alpha, Ursa Major, or Uma. This is not named after Uma Thurman, the actress. This is Ursa Major, the Ursa bear. Major means big, the big bear. You will find your way by pointing 5 times their angular distance apart, 5 degrees. 1, 2, 3, 4, 5. Come to the North Celestial Pole, which is not there in the real sky. But we are lucky to have Polaris, the pole star Polaris, Alpha Umi, Ursa Minor, the small bear. Now, I've turned down the brightness of the sky on purpose. So I set a limit to what we can see, a limiting magnitude. You see this 5.3? If I take that off, then the star that didn't show up in the Little Dipper came back. Usually we use these 4 stars for the bowl, 3 for the handle, just like the Big Dipper. Yes? No. 7 stars in the Little Dipper, but on a clear night, you can actually see 8 if you have good eyesight. The bottom star in the handle is down in the trees, 1, 2, 3, 4, 5, 6, 7. But if you look carefully at the bend in the handle, there's a apparent double star. They don't move around each other, not a real double star. They're not bound by gravity. But Mizar and Alcor are a visual double. Mizar itself, Mizar is a spectroscopic double. 2 stars revolving about each other. There are lots of multiple star systems in the sky. The sun seems to be a rarity, a single star. Or maybe we have a companion. Maybe we have a giant planet out there or a black hole. Planet 9 or a mini black hole the size of a grapefruit. We don't know. Not yet. Keep looking. You might find Planet 9 or you might not. So we just did some star hopping to use the Big Dipper to find north. And so if you can find the North Star, you can always find north. You might miss the dragon in the trees this time of year, but very high up, you'll find the letter M for Cassiopeia, the queen, and the house-shaped group of stars is Cepheus. And if the sky is really clear, I challenge you to see those shapes now. This is why I turned down or made more light pollution by limiting my magnet to about 5.5. 5.5 magnitude. If you can't see any fainter than that, that's generally the kind of skies that most of us will see in suburban skies. And that's why I like to leave the lines up to help me, because I can't find constellations without them. I need a star chart. So you just found several constellations that never rise or set. They just spin round and round and round the North Pole because they're very close to the North Pole. But the further away you go, stars are going to rise and set from the east to the west. In the west, we have Aries the Ram setting. This is a springtime constellation. I'm Triangulum, go ahead, guess. This is a tough one. Triangulum, what is that? No idea. Aries looks just like a ram. It's incredible. Horns, hooves, and what's this? Cetus? Is that Cetus? I don't know. Well, I could cheat. I can put up names. The whale or the sea monster, depending on how you look at it. The sea monster that tried to eat Andromeda, the daughter of Cassiopeia, who boasted that she was more beautiful than Hera, the queen of the gods. Now, if you read Greek mythology, you'll know that is the worst mistake you can make. You could call Jupiter dumb. You'd risk being hit by lightning, right? You could say, Mercury, you're the slowest. But if you tell Hera she's not beautiful, big trouble. Created the story of Perseus and Andromeda. They're out there in the sky. But in the winter, we don't talk about spring constellations. We face south and see Orion just about due south. Where is S? There it is. Due south. We can use Orion as we did before to star hop upward toward the east to see the Taurus, the bull, the Hyades star cluster for his face, and the Pleiades. Or we can star hop down the other way to the east and find the dog star Sirius. This is the second brightest star in the entire sky. Anyone know the name, the Latin name of the brightest star in the sky? Latin name? This star is 8.6 light years away, Sirius. There is a star that's 8.3 light minutes away. If it turned off, we wouldn't know about it for 8 minutes, more than 8 minutes. What is it? SOL, Sol, the sun, right? That was a trick question. But if you can find Sirius, and if you can find Orion's armpit, Betelgeuse, yep, look it up. Literal translation of the Arabic Betelgeuse, armpit of the giant. You can find two of the stars of the winter triangle. We had a summer triangle, now we have a winter triangle. Betelgeuse, Procyon, before, coming before. Scion, the dog. Coming before the little dog is the big dog. Or coming before the big dog star. As the stars rise in the sky, let's go back in time, shall we? 20, 19, 18, 17, 16. Procyon comes up first before Sirius, rises first. It's a harbinger of the rising of Sirius, brightest nighttime star from the northern hemisphere. I'm going to go back again. I can go right back to real time, to the current time. 8:38, 50 seconds, 52 seconds. It's counting down. So we can find the winter triangle, 3 bright stars is fairly easy. And Orion, the Orion constellation, is fairly easy. A little more of a challenge is the winter hexagon, because now the hexagon of 6 bright stars has an extra one that's not a star. It doesn't twinkle like the other stars. If we start with the bright star Sirius and go to Orion's ankle or foot or knee, this is Rigel. Up to the eye of the bull, Aldebaran. Over to Capella in Auriga, the chariot. No, Auriga is the shepherd. He's carrying baby goats. Do you see them? Right there. 3 little goats. And then over to the stars of Gemini. There's Pollux down to Procyon. Let's do it again. Winter hexagon. If you can find Orion, it might be easier to start with Rigel 1, Aldebaran 2, Capella 3, I hit the wrong one, Pollux 4, Procyon 5, Sirius 6, winter hexagon. But there's a nice bright planet right there. I can zoom in on it. It's a very bright planet, brightest after Venus, and that's Jupiter that we saw before. Right now, the moons of Jupiter are splayed out differently, 3 on one side, 1 on the other. Largest moon in the solar system is Ganymede. So about as big as the planet Mercury. These things would be planets in their own right if they weren't orbiting Jupiter. And that's what you might see in a small telescope. If you visit us or bring your own telescope, we can help you set them up when we're open in the warmer weather. You will see the bands of Jupiter, thousands of miles wide. In some of our larger telescopes, you'll see some detail. And if you're lucky, you might see the red spot. It's disappearing over the limb of Jupiter. Might see some storms. Generally, in most scopes, it'll look like this or worse. And the Earth's atmosphere gets in the way, so it will blur things a bit sometimes. And if you wait long enough, it will not only stop blurring and be clear, but it'll drift out of your field of view in your telescope like this very slowly. Why is the sky moving like that? If I set up a telescope that's still and just aim it at something, this is what happens. It goes right out of the field of view, and you have to push the telescope back again. Why? What's moving? Earth. Earth is rotating, right? So the whole sky is moving. You don't notice it unless you're looking through a telescope. The planet Jupiter is amongst the stars of the twins, Gemini this month, nice and bright. What else can we see? If we look above Orion, we can follow Sirius to Betelgeuse, and that will point us to Gemini. Amongst the stars of Gemini and the Milky Way, our galaxy, we can sometimes see some interesting things here. What's this? So a bunch of stars clustering together. So of course, the name's going to be hard to figure out. What is this? It's a stars clustering together. Oh, star cluster. Brilliant. Yeah, this is a star cluster in the form of a globe. So astronomers call it a globular star cluster. There are tens of thousands of these things circling our Milky Way galaxy in all angles, all directions. They are amongst the oldest things in our galaxy, billions of years old. There are some nice glowing gas clouds called nebulae. This is hydrogen gas, most abundant material in the universe, glowing with its own light. Now, of course, this is long exposure pictures that we're showing here. So to the human eye, looking through a telescope, everything looks kind of greenish. That's what our eyes are sensitive to, the green part of the spectrum. So don't be disappointed, right? It's really just fun to see if you can find these things and see them at all. But there are some very pretty pictures up there. One of my favorites looks like a flower amongst the hooves, tail, horn, and head of a horse-like animal. Think about that. This nebula looks like a flower. What is that? Take a guess. Look familiar? I've mentioned this many times before. It's one of my favorite emission nebulae, hydrogen gas emitting its own light, and it's called the Rosette. And the constellation that you find it in is right next to Orion. It's the Monoceros 1, Ceros, horn, just like rhino nose ceros, rhinoceros, nose horn. This is a horse horn, or mono, one horn. Little dog, right? It looks just like a little dog. It's amazing. Look, I'll take the picture away. It's amazing. Canis minor. It looks exactly like a little dog. Incredible. Our ancestors had more clear skies than we did. And they had more, what? Time. More time. Clear skies. They'd be out there 11 degrees, that wouldn't bother them, or would it? I'm just glad we can be indoors and see the stars comfortably. Go outside, challenge yourself, bundle up, look at the skies of winter. They're amongst the clearest skies ever. You can challenge yourself to find minor constellations like this one, leaping away from the hunter quickly, like the bunny that we saw in our yard today. This is Lepus. What's Lepus? It's an Hare, bigger than a bunny. Maybe it's being chased by Canis Major. Maybe it's trying to escape the long constellation, the snake-like constellation. I don't know what that is. That's something you'd see in the southern sky. We can even put up names. Yeah, Fornax is going to be hard to see from us, but Eridanus is the river. The river. Bunny's going for a drink. So removing all this stuff gives us a realistic sky. You won't find labels for the stars either. So what would I recommend for beginners or even advanced people who don't get out all the time to see the sky? Get yourself a star chart like the kind we sell at UACNJ. Start over in the north, get your bearings, and then look at the stars disappearing in the west. Planet Saturn is gone early. Planet Uranus is there. Look at that. Uranus is not far from the Pleiades, if you want to look at it. And a telescope, you're going to need a telescope to see a disk. My small telescope can barely see a bluish disk, just barely, no features at all. Large telescopes show a brightening along the equator. That's about it. It's mostly clouds. 5 times the size of Earth, a gas giant. Made, now we know, made mostly of not gases. Gases in a very peculiar state. Can we see the rings of Uranus from the Earth? Can we see it from a space probe? Yes. From a telescope? Nope. No. But we can see some moons. Can't see all of them. Saturn holds the record currently, about 164. Yeah, lots of moons inside the rings of Saturn. But Saturn's not visible right now. Tonight it's the dwarf planet Ceres, the planet Uranus, the planet Jupiter. You can work your way over from west to east using Orion to point eastward to the Bull and the Pleiades. I'm sorry, westward. Then left is eastward to the dog stars, Sirius, Procyon, and over to the stars of March rising in the east, which I'll be talking about more. More about Leo, one of the first signs of spring in what's up in March. But we have some other exciting news. I can come back to the sky. Let me just conclude with some remarks about how you can get started in astronomy. I like reading. Does anybody out there still read? Or do we scan? There's a new reading pattern we've discovered. Most people will start with sentences and then kind of collapse them down to the left and downward. So it's kind of like a delta shape or a V going downward, reading faster, faster, and less. But if you still like to read, try Sky and Telescope magazine. It's in print, it's online. You can subscribe, you can get parts free. Or Astronomy magazine's been in print almost as long, well, not quite as long as Sky and Telescope. Lots of articles about everything, observing and news are my favorite, but there's other things in there, space exploration. Stores, they sell all kinds of stuff. Space.com, I think, is the easiest to remember. If you forget anything else I said tonight, that's pretty good. Space.com, they've got all kinds of news, the search for life. They have stargazing apps, the best ones by category, like this, 2026, 2025. They categorize them for people who are Apple users or people who are astrophotographers, or if you're just a beginner. I shouldn't say just, I was a beginner at one time. We welcome beginners into amateur astronomy. It's a lot of fun. It's mind expanding. It really is. When you contemplate the vastness of the universe and our place in it, where we are so insignificant in size and time, but we make ourselves significant by dint of our effort to understand the universe. We are part of the universe, which makes it hard to know it all, but we can learn and understand a lot of it. There are some apps that are good for realism and entertainment. I like Stellarium. That helps me find my way through my light polluted skies in Bergen County. I like Skyview. There's so many. There's like a couple dozen at least. So if I go back, here's a planisphere, the kind we sell at UACNJ. Boy, I've mentioned that too many times. That's enough advertising. Come on and visit. Giant binoculars have come way down in price over the years. I bought a pair way back when Halley's Comet came by close to Earth. It's coming back again in the year 2061. I hope I can see it. The prices are very good. I recommend not getting standard bird watching binoculars, not a 7 by 35 or 7 by 50. The first number is the magnification. How many times bigger? 7. The second, 50, is millimeters. Divide by 25.4, that's about 2 inches. That's too small. Get yourself big binoculars, 70 or 80 millimeters. I have 9 by 63s. That works pretty well. Size of a small telescope. And something solid to put them on, like the roof of a car or a railing or even a tripod. I recommend that. So there's give you an idea of some of the prices. And finally, how to get started. There's very good articles on all these references. Astronomy Magazine, Sky and Telescope, Space.com, even telescope sites like Celestron, Mead, although one of them's going out of business. And I check these websites for events, Go-Astronomy, Star Walk. I showed you something from Star Walk earlier. Even space.com, if you can't remember anything else. Or if you're taking pictures of my screen, I can leave it up for a few seconds. These are good places to go again. I just use them. I don't work for them. And they're great ways to get started learning about astronomy. We happen to have, because February is so sparse in events, we have some interesting note coming in March. A Kreutz comet, a sun-grazing comet, broke up a long time ago. It was a giant comet, broke up into pieces, and it's in a family called the Kreutz comets. This one, C/2026A1MAPS. It's a long name. It's hard to say quickly. I'm going to abbreviate it, C2026A1, discovered by 4 people, and those are their initials, MAPS, on a kamikaze orbit right past the sun. It may break up again. It may survive. The part that is coming by is 2.4 kilometers across. It looks like this on the 17th of January, when it was extremely faint, not visible unless you were using one of the world's greatest telescopes. But when it comes to its close Helios, sun god, perihelion, close to the sun, it's going to be so close it may burn up. In April, it'll reach negative magnitudes, -4 for Venus, 0 for Saturn. Some of the planets get to minus magnitudes. The moon is -11. It may be visible to the unaided eye very easily. It's something to watch out for. It was discovered by these 4 people, and so their name abbreviations are part of the name of the comet. I've thrown a lot of stuff at you. Tonight, I'm going to wrap things up with a quick review. Don't forget, Mercury is highest away from the sun, but it's close to a thin crescent moon on the 18th. Highest away from the sun, the 19th. Check it out on the 18th and the 19th. Good time to find other things in the sky too, right? Not only Mercury. But if you're looking at Jupiter in a telescope, Io and Europa may merge into one star. Unfortunately, I didn't mention there is an eclipse of the moon coming in March. I'll talk about this in detail. The unfortunate thing is that we can't see the whole thing in New Jersey because it'll be setting while half of the moon is covered. But it'll be a nice sight. And I'll talk about that in, you guessed it, what's up in March. And with that, I'm going to direct you to my website, which I've recently completely upgraded, tripling the number of 3D worlds that you can play with. I had 8 before, there's something like 30 something now. I doubled the number of my paintings and artwork. Check it out at the gallery at astronomyinmotion.com. The 3D objects you can move with your fingers if you have a mobile device. And nowadays, who doesn't have a mobile device? Who doesn't like to use a mobile device? My brother-in-law, but that's okay. I'm old-fashioned too. I have an old mobile device. If you have a tablet, a phone, if you have a joystick, a mouse, anything, you can work these things like the planet Saturn or the asteroid Apophis that's coming close to us in 2029, within the orbit of our satellites, closer than the geosynchronous satellites at 20,000 miles. That'll be exciting. You can look around, you can move on these things. If you look at virtual Mercury, you'll have 4 hotspots. If you click the information, you can hear narrations, videos, short, snappy videos narrated by my wife, who shamelessly I have failed to pay for her work. But check it out. It's a lot of fun. That's where you can find me, my contact information at Astronomy in Motion. But you can find UACNJ everywhere: Instagram, Facebook, uacnj.org, Discord, Patreon, YouTube. We're everywhere. I want to thank you for being such a good audience. If you have questions, now's a good time to ask. I'm going to turn things back to Kim. Thank you very much. And thanks, Kim.
All right. Thank you, Lonnie, for another great presentation. As he mentioned, we're doing question and answer now. So if you happen to have held a question till now, for whatever strange reason, instead of typing it into chat, I do suggest you get that in there. But we're going to start things off with the first online question, which was, are there problems with telescopes and such when the weather is this cold?
Oh, that's a very good question. There's a problem for the observer. The it's not comfortable, but winter skies tend to be a steadier viewing than summer. The colder air evidently is more stable. You still have to wait for a time for the atmosphere to settle down if you're looking at something like a planet and you want to see detail. But it is, I have to say, easier in the winter. The problem is you're standing still unless you're shifting from foot to foot, like you have to go to the bathroom. But I recommend layers. Layers are very good, like a fishnet first, with open holes in it that can trap air. And then cotton is not generally good if you're exercising because it retains sweat. But in the winter, you might want to put a cotton layer over that and then something loose over that, like thermal, and then a vest, like an insulated vest, and then your insulated coat. Wear something over your head, at least one, please, and protect your hands, right? So even soft, small gloves if you have to manipulate equipment. But please be careful. Do not get frostbite. And if it's this cold, I'd recommend waiting until the night's a little bit warmer. We're coming up on around freezing, 30, 32-degree weather on Monday. So maybe things will be a little bit better than this weekend. That's a good question.
Yeah, I did reach out to some of my more technically inclined volunteer friends, and the response I got from them is usually the telescope itself doesn't have too many problems. Uh, there's not really many moving parts that would have a problem with the cold. What can sometimes have trouble with the cold is actually the mount you have your telescope on, because it depends on what type of grease you've used, whether that will end up frozen up.
Right.
So thank you, Chris, for giving me that answer because I did not know that.
Good point. Yep.
But one of the pros of being part of a club is you can reach out to people and when you don't know something and go, hey, what's the answer?
That's right. We like questions. When we do these live, you can ask lots of questions. Amateur astronomers love it.
Right. Uh, Let's see. And a comment that I made when you were talking about giveaway objects, technically, there is a possibility to do such things with our online merch store, but it would require some activation, and I don't know whether that would actually work in the YouTube chat. It definitely would work with Twitch chat. So, uh, there's a possibility, but that would require some setup and some seeing how viable it is.
I have to
I
say,
think that would be something where we would have to set, you know, we reach this sort of milestone with stream before we start trying to do giveaway items. So
yeah,
if you,
I'd like the audience to know that people like Kim and Chris have been working behind the scenes for years, upgrading everything, the technology, making things more easier, adding streaming. You know, at one time we did everything at site, and now we have streaming. We've got a lot of sophistication going on, and that's because of all the diligent volunteers.
but yeah, uh, I I'll probably have to go back to our board and run it past them about what goal we might want to set if chat decides to grow the community a bit and s- meet some goals, we might be able to pull that sort of thing off where we start doing giveaways. I can make no promises, uh, but it's not impossible. Uh, I'm gonna ask if anyone has any questions. Oh, our viewer on Twitch, Fire on Stan asks, how did ice get on Europa's surface?
Ah, excellent question. The outer solar system had a lot of light materials that didn't get burned away when the sun turned on billions of years ago. So there's still a lot of ices of all type. A lot of substances are in ice form that far out. Methane, ammonia. There is a lot of water in the solar system. We've been discovering it in all kinds of weird places, on Ceres, the asteroid, on our own moon, perhaps at the South Pole. So it was always there. And Europa, like other moons near the giant planets, is light. It's not very dense. There's a lot of water in it. An ocean that's perhaps hundreds of kilometers or miles deep. So it's a good place to look for life. And there are some organic compounds, hydrogen compounds besides methane, ammonia, some complex organic molecules. So are we going to find life there? We won't know till we drill down below the ice. But there is a good possibility we'll find something.
Perfect. And our next online question is, how much warning might we have if a comic, if a comet was bound to strike Earth?
We have virtually no warning at all when a comet strikes the Earth. A new one will pop up at any time, but comets, we can see them coming. The detection of this new one set a record because we have some of the world's new giant telescopes that have been online for a while now can see very far out. The Vera Rubin Observatory is coming online, and that has the world's largest digital camera, powerful enough to scan the entire sky within 3 days. Every 3 days, they'll scan the entire sky. It will discover new asteroids, the precursors possibly of dark matter, might give us clues as to what dark matter is. So we can see these things coming a long way off. The problem is the smaller objects, the smaller near Earth asteroids or near Earth objects, commonly called NEOs. And for those, we could use a dedicated telescope placed at L1, a gravitational point towards the sun, about 1 million miles away from Earth. We have one, we have a telescope 1 million miles away from the Earth, and the other side at L2, pointing away from the sun. That's where the James Webb Space Telescope lies. But we need to watch out for the small stuff. Comets, we can see them coming because as they heat up, stuff sublimes directly from solid to gas, and that's what's creating that tail, some of the tail. Some of the tail is gas, some is ionized material, electrically charged. So a lot of stuff going on in a comet.
Yep.
Good questions. We have some very good questions tonight.
And I don't know if chat heard this sneeze, but I have stolen one of our volunteers' dogs named Hubble, and I figured I'd do the puppy tax thing for chat, so I'm just gonna scoot the mic away a little bit. Hubble, come here. Come here. Come here.
He's a dog star. Somebody had to say
You
it.
gotta get up. Come on, get up. Now come over here. Hubble, come here. Up, up, up. You do not know up? Come here. Come here. Come up here. Yeah. I don't know if Jack can see. There we go. I got the puppy. Good boy. Okay. Puppy is not much for I say puppy,
There-
it is a full grown dog, but puppy is not much for jumping up.
So, some of them are squirmy like puppies.
But I figured chat might get a kick out of Hubble, aptly named because his owner is one of our astrophotographers, uh, who actually has photos in our yearly astrophotography calendar that you could get when at the site. That reminds me, I need to start making uh, the next one for next year. Right. Let's see. And there was a comment in chat that they're booking their trip to Mars before the next comet could possibly strike.
Ah,
So,
good planning.
uh, were there any last minute questions? I know that we kind of distracted there with the puppy for a second.
Puppies do
And
that.
yeah, but I figured people would get a kick out of it. Something different.
All right, so everybody's expert at the sky, right? What are you going to do? You're going
Uh,
to go outside and be confused? No. Let's see. Well, a good strategy is see if you can
oh,
identify stuff in the north.
yeah,
Whoa, dizzy.
he has
And
stuff
then
up on
work your
his
way back over to
screen.
the east. And you might want to try for the planet Jupiter. That's pretty bright. Nice, nice target. Just don't freeze, please. Be safe.
Yeah, I think there's an old proverb by some some culture that lives like European continent, where it's like there's not bad weather, there's just poorly dressed people.
Yeah.
So do dress appropriately. Uh, I know recently at the observatory we had an instance where uh, one of our pipes froze. We've since got that fixed, so
Ooh.
woo! It has been quite cold. Last chance for chat to get any questions in. I'm gonna give you a couple seconds or couple seconds, a couple minutes for that. Once again, Lonnie, I do want to thank you for another great presentation. I do also want to thank everyone who's joined us both on YouTube and Twitch. Uh, if do hit those free actions, the like, the follow, the subscribe, depending on which site you're on. Usually they're down below on the bar there. It does help us get word out to more people, and the more people we can reach, the more fun things we can do, and the more interesting things we could do. Uh,
Also, don't forget we do this every Saturday. Mine is only once per month on the first Saturday, but we have other programs.
yep. For winter, because some of us actually uh would like to take vacation. We do occasionally do reruns. Next week is a rerun. Um, and we'll probably be working on various things to start getting the observatory ready because we will open the site back up, our site in Hope, New Jersey, come April, which is just 7 weeks away,
Hmm.
which really isn't that far off when you start thinking about it. That'll go by in a flash. Our next live program is actually the 21st, and that is with Astro Canuck on Twitch, and he'll be giving a presentation on his journey through uh, being a space communicator, a science communicator on Twitch, and some of the space Lego builds he's done to accomplish that. So that should be fun. Uh, all right. So it does look like our questions have come to an end. I do want to thank everyone. If you haven't already, do check us out on our website, uacnj.org, as well as follow us on our social media, our Instagram, our Facebook, our Discord servers. They're all great places to get in touch with us, ask questions, share your photos, whether it be of your astrophotography, that weird thing in the sky you're not quite sure about, or just showing off the haha, don't you wish you had this sort of equipment? Uh, we do love to see it there. Thank you all. With that, I want to wish everyone clear skies, good seeing, and see you next time.